If the English language has A to C for its alphabet, the decimal system has 1 to 9 and 0, not 1 to 10. And the decimal alphabet of 1 to 9 and 0 is the justification to a 9-beaded Filipino abacus. An abacus that is 9-beaded as a decimal abacus should be. The billion, the million, the thousand, and the unit periods are separated by color for the children so that they can tell at a glance one period from another and later on move the beads without counting. Presently, there are 10 columns to the Filipino abacus, 1 column under the billion period, and 3 columns each under the million, the thousand, and the unit periods for the repeating hundreds, tens, and ones places. Again, there are 9 beads to each column of the Filipino abacus, which means that the most that one can go under any column is 9. 999 for the unit period. It is available in different designs, plastic for the children, and a version for the teachers, and a limited edition in hardwood. Let us frame the learning of the abacus on the generally accepted mastery objective for teaching numbers to children in the early grades. Mastery of the concepts of base 10 and place value to 100 by the end of the first grade and to 1000 by the end of the second grade, which is a paraphrase of the mastery objective that the National Council of Teachers of Mathematics of America has set for American children. The experts who drew that mastery objective believed that everybody knew the meaning of the concept, and the textbook writers believed that they knew. Sadly, both were wrong, so that for a very long time now, we've been teaching the children to count when we should be teaching them the concept of place value in the decimal system, passing counting for place value to innocent children. No different from directing the archers to point their bows and arrows southeast when the target is in the east. Building the 4 fundamental operations not on place value but on unsound ground, which is counting. The result is widespread matophobia. But why place value in 100? Why in 1000? Why by the end of the second grade? Why not place value in 10? And from 10 get the children to leapfrog to 100 and 1000 in kindergarten. Because if we can get the children to see 10 ones in 10, we can also get them to see 10 tens in 100 and 10 hundreds in 1000. 10 is like an iceberg with a large part of it underwater with 1 and 0 at the tip. If we are to teach place value in 10 for mastery and understanding, then we have to show the whole iceberg. Here is a snapshot of 10 showing the visual aids, the manipulative, the mental tool that language is, that are the building blocks to the construction of the meaning of 10 and place value in children's minds. Teaching aids that complement one another, that through regular oral class-wide reading and hands-on drills convert into blocks of experiences that construct into the knowledge of place value in children's minds, and thus expose the fiction to discovery in constructivism. There is the period HTO chart, there is the abacus, and there is the counting chart. We will begin with these 3, but introduce the children first to the concepts of numerosity and 1, and to counting to 10 using the permanent counts. To see 7 in the 7 days of the week, not in the numeral 7, 5 in the 5 digits of the hand, and 10 in both, 6 in the legs of insects or the sides to a cube, the permanent counts, not in the numerals, at least not yet. Next, connect the lesson on the permanent counts to the counts to 9 and 10 chart. And then in regular oral class-wide reading drills, convert the counts to 9 and 10 chart into sight counts. Now, back to the period HTO places chart, the abacus, and the counting chart. Display the 3 prominently so that the children can see them even before the lessons on numbers start. To get them to ask questions. Why the 9 beads? What's the HTO places all about? Why the 1 to 9, 10 to 90, 100 to 900 pattern? why not 1 to 10? One way of teaching without teaching. In kindergarten, insert the period HTO places chart in language arts, in reading and phonics lessons, and convert the number words into sight words that children can read from any direction. Preparing the ground, or in legalese, laying the predicate. While the children are absorbing the period HTO places chart, introduce the abacus and mix match the two in regular oral class-wide drills. Direct the children's attention to the HTO places common to both, to the 9 beads on the abacus and the repeating 1 to 9, 10 to 90, 100 to 900 pattern. Read the period HTO places chart, then do the drills on the abacus. 1 to 9, 10 to 90, 100 to 900, and 1000 to 9000. If we are true to language acquisition as a learning paradigm, then even before the mix matching of the HTO places chart with the abacus, we should have at least introduced the counting chart to the children. Read the counting chart to the children and then later on regularly with them. In regular class-wide drills, get the class to count to 10, to 100, and to 1000 using both hands to strengthen their understanding that 10 is 10 once, 100 is 10 10, and 1000 is 1000. And then combine the three. The period HTO places chart, the abacus, and the counting chart. Emphasize that 10, which is 10 ones, is 1 bead on the abacus. 100, which is 10 tens, is 1 bead on the abacus. And 1000, which is 10 hundreds, is 1 bead on the abacus also. After weaving in children's minds through regular class-wide oral reading and hands-on drills, the period HTO places chart, the abacus, and the counting chart, it will now be easy for the children to read the 3 beads raised on the abacus as 1110. But more than that, explain further that 1000 is 1000, 1 bead on the abacus, 100 is 1010, 1 bead on the abacus, and 10 is 10 ones, 1 bead also on the abacus. A representation of 1110 on a decimal abacus and in the decimal system that is common to the Egypt of Akhenaten and Cleopatra, the Greece of Aristotle, Alexander, and Archimedes, the Rome of the Caesars, the India of Ashoka, and the China of the first emperor Shi Huangdi. The history of the decimal system spanning thousands of years to the time the modern decimal notation was widely accepted in the West in the middle of the 17th century was about the history of man trying to simplify the decimal system. Dr. Andrew Wiles of Princeton University in June of 1993 solved the 350-year-old Fermat's last theorem, and it was front page news the following day. In contrast, it took man more than 2,000 years to simplify the decimal system. The best minds of Egypt, the best minds of Greece, combined with the best minds of the Roman Empire for almost 3,000 years failed to simplify the decimal system, and the question traveled back to Egypt and from Alexandria traveled to India. The Hindus are credited with having solved the problem and invented the modern decimal notation. We believe, however, that India's invention of the modern decimal notation was less of an invention and was more of a serendipitous find in Chinese numeration and its repeated use of 1 to 9 like an alphabet. In the court of the Chinese Emperor Ming-Ti, who introduced Buddhism to China in 58 AD. The credit therefore should go to the Buddhist missionaries of the third emperor of the Indian Maurya dynasty, Asoka. In the 10th century, it reached Arab Spain. In 1202, Leonardo Fibonacci wrote about it in his book Liber Abaci, and in the middle of the 17th century came to wide acceptance, supplanting the almost 2,000 years old Roman numeration, sending the Roman abacus to oblivion. Thanks to Kublai Khan and Marco Polo, the Roman abacus lives on in the Chinese abacus. Thus, India exported Buddhism to China and imported the numerals 1 to 9. The numerals 1 to 9 considerably improved the decimal notation, But like Dr. Andrew Wall's solution to Fermat's last theorem, it was incomplete. Thanks to Sunya, the concept of the void in Indian philosophy, reified as 0 and used as placeholder for no count, it completed the decimal alphabet of 1 to 9 and 0 and the notation to the modern decimal system. 0, the only numeral unaffected by place or position. Use the words decimal alphabet in talking with the children and have them use the numerals 1 to 9 and 0 in their writing drills. With the decimal alphabet of 1 to 9 and 0, we can now explain the concept of place value in 10, and from 10, leapfrog to 100 and to 1000, and with 1110 in the decimal abacus, explain the concept of place value in the decimal system in one sentence. 10 is 10 ones, one bead on the abacus, represented by the two numerals 1 and 0 from the decimal alphabet. 1 is for the bead under the tens place, representing 10 ones, and 0 is a placeholder for no count for the empty ones place. But 10 is more than that. Plus a little more, the maps to 9 and 10, for example, that we will use as mental tool to see the numbers to 9 and 10 in all their forms and guises. Knowing now what comes with 10 and with the whole iceberg under 10 in full view, we can now leapfrog from 10 to 100 and to 1000 and explain the concept of place value in 1110. That in the decimal system in 1110 as example, any 1 is 10 times the 1 to its right, while 0 is a placeholder for no count. With the concept of place value as foundation and with the maps to 9 and 10 as mental tools, we can now go to the next lessons on addition and subtraction to 9 and 10. Use the counts to 9 and 10 chart to introduce addition and subtraction to the children by directing the children to see 5, for example, as the combination of 1 and 4, 2 and 3, 5 and 0. 7 as 0 and 7, 1 and 6, 2 and 5, 3 and 4. Using the counts to 9 and 10 chart to introduce addition and subtraction and the maps to 9 and 10. We couldn't get a better example of teaching for mastery and understanding than getting the children to learn the maps to 9 and 10 intuitively. And use the maps to 9 and 10 in regular class-wide oral reading and writing drills in addition and subtraction to see the numbers to 9 and 10 in all their forms and guises. From the regular class-wide addition and subtraction drills using the counts to 9 and 10 chart and the maps, continue with the drills on the abacus. Conduct class-wide addition and subtraction hands-on drills to 9 on the abacus with the maps as guides. Repeat these drills regularly, these class-wide addition subtraction drills to 9 on the abacus. And then on 10, with the map of 10 as guide, conduct regular class-wide addition and subtraction hands-on drills. With the regular addition, subtraction, hands-on drills on 10 on the abacus, use as often as possible the word regrouping. Here we are now in our final lesson in addition and subtraction with simple regrouping to 19 and from 19. Using the counts to 9 and 10 chart as guide, train the children to see 11 as 110 and 1, 12 as 110 and 2, 13 as 110 and 3, 18 as 110 and 8, and 19 as 110 and 9. 110 and 1 for 11 may sound peculiar to Western ears, but it is a distinctly Oriental way to put it. With the Oriental used differently, if not opposite, the sense Edward Said used it. And notice the difference between adding 110 and 7 to 110 and 2 with adding 17 to 12. With the concept of place value in the decimal system as a foundation and the maps to 9 and 10 as mental tools, observe how 9 plus 9 on the abacus regroup as 8 and 10 and how 15 minus 9 regroup as 5 and 1. do the addition and subtraction drills on the abacus in slides 97 and 98, following the arrows to each exercise on how to do it on the abacus. Repeat with the maps as a guide and with mastery and understanding in mind. Sana ay maraming grasya po ang dumating sa Pilipino.